So, welcome everyone. We are about to start the conference. So, welcome to the new edition, the 2025 edition of the BIM A Plus International Conference. So, I would like to welcome everyone that is present, both in the rooms of Uming or in Ljubljana, or even watching online through our YouTube channel. Welcome everyone. You can interact with us through the chat in YouTube. I see already someone saying already commenting. So we were a little bit delayed. That's why there was nothing being shown. But I hope that now it's everything okay. So this is a joint venture between the University of Minho and the University of Ljubljana to showcase what is being developed by our master students, and there will be the opportunity of all of them to do the presentation. Okay. So, as I said, this is both universities are organized together to handle this master and this conference. This conference focus on building information modeling and how this can promote the share of knowledge and create a discussion forum and engage the community about the digitalization. This is the focus of this conference. We are here to share the knowledge and share everything. All the presentations will make available on our YouTube channel, and all the dissertations will also be available on the BIM A Plus Master website for all of you to inspect and share and get deep on some work that you might find interesting. Also, tomorrow we'll have an invited speaker that is always very nice to share other visions of people with more experience on the topic. And this year will be Letizia Martinelli from the CNR. CNR is the National Research Center in Italy. And specifically, Letizia Martinelli is from the Institute of Heritage Science. And she'll be speaking about the heritage BIM for management, conservation, and energy improvement of historical buildings. So keep in touch or keep following the conference if you are interested in heritage BIM. That will be a very interesting talk from her. Also, this is a big group of associations and institutions and companies that manage all these master and also this conference. So I would like to thank the institutions of the organization, the University of Minho and the University of Ljubljana, as well as all the associated partners that are here listed that we have from universities, R&D institutions, non-profit organizations, BIM consultants, design offices, contractors, and software houses. Okay, a big thank, because all the work that will be shown here is part not only of the two main universities, but also a lot related to some of these associated partners that are together with us, working with the students to deliver the best works possible. So this is our program that was available on the website. Unfortunately for today, we have a confirmation that one of the presenters will not be available. So Daria will not be with us presenting due to last minute changes. But either way, we'll have all the other presentations, and I hope that you will enjoy. So this is the first day that will be composed of 2 sessions with the break in the middle. And then in the second day that we'll have the 4 sessions with the invited speaker speaking in the first session in the morning of day 2. And you will be able to witness all these presentations. Okay. And I will just like again to thank all the people involved already in the preparation of these presentations, and also for Miguel Azeng and Thomas Serovsek, that are the master coordinators in each institution for the enabling the creation of all this course and all these opportunities to create this conference. And I will pass now the speech to the first chairman of the session, that is Thais Soares, that will manage the first session, and I hope that everyone enjoys the conference. Thank you.
Thank you, Granja, for the warm welcome. Sorry. We will start the first section now with the first presentation from Agnes Bacadi. I would like to invite her. The title of the presentation is Exploring Agent-Based Models for Construction Planning Using Partial 4D BIM Models. You have more or less 10 minutes, and then we'll have some minutes for questions. 15 minutes, sorry.
Hello, my name is Agnes. I'll be presenting, as Tai said. My topic is about it's about exploring the agent-based models for construction. So the agenda will be about the introduction, the methodology, the results, and the conclusions that were obtained from the thesis itself. So the problem statement is that in the construction industry, it's 20% of the global workforce deaths are attributed by falling from heights, which is according to the International Labour Organization. So it's about, despite the advances in digital planning tools, construction sites are still presenting dynamic and unpredictable hazards, which only emerge during execution. So the project is planning to, or rather it's addressing the gap by exploring how an artificial agent, which is trained via reinforcement learning, can proactively identify fall-related risks by interacting with a virtual 4D BIM construction site during its incomplete stages. So, like I stated, the tools are quite basic, static, predefined rules, no continuous feedback, and you cannot detect the emergent risks. So here we developed a R-compatible 4D BIM environment in the game engine of Godot. Then we trained the agent to explore, identify, and interact with all the fall-related hazards. Then eventually we evaluated the actual hazard-seeking behavior versus the expectations that we had set before. So the first methodology was we were to prepare the BIM model in an export and export it via IFC. This was done in Revit. Then it was the model itself was further optimized in Blender to remove other aspects of the MEP structure that was not needed for the game engine, as it would have become very heavy. Then after that, we went into Godot, where we defined what the agent would be doing, training, and also its analysis. So in basic, that was how we did the first part. Then when we moved to the agent configuration in Godot, it was a matter of the agent would randomly spawn each time he fell off or each time anything happened. He would randomly start from a different position so that it would be able to ensure that the agent was interacting with the environment completely. So we used the GD script, which is a component of Godot with a combination of Python programming. So via the agent stable lines, basically, we were able to configure how the agent would move. So the agent would move using the raycast sensors. There would be no predefined notion as to how he would move. He would just autonomously move based on the sensors. And then this logic was a bit inverted. Normally in safety simulations, you try to make sure that the agent is avoiding hazards. But in this case, for the project, we made it in the invert such that if he fell or if he interacted with any hazard, he got rewarded for that. Then we also had an action space where we would train the agent to either move forward, backwards, or even turn left or right. In the case that he was he was stuck for a longer duration of time, more than 60 seconds, the game would reset and it would start all over again with a new episode. So yeah, here's the environment reset workflow. So we have the random agent where he starts, and then if he reached either the maximum number of steps, or he got stuck for too long, or he actually interacted with the hazard, the game would end, and then it would start a next episode. So the next episode would also start in such a way that he would continue to log the cumulative rewards that he got, which was then continued to the next. So it continued as a cycle for a lot of episodes, which was about maybe 2000 for some. So in this case, when we're talking about an episode, we were talking about, this is how we defined an episode. So it would run, it doesn't matter what the duration of time was, if it reached the timeout level, or if the agent fell, or if it got stuck, then, or we manually reset it, then the game would end. And then the agent would start again from a different position. So the expectations of this dissertation was that the agent would have learned how to seek for hazards. He would navigate the building. Particularly, we were aiming for him to fall off the building, not to use the stairs. There were stairs included in the BIM model, but we wanted him to be able to figure out how to interact with the space in such a way that his reward logic was based on falling. And then if he explored different spaces in the BIM model, he got more points. And also we were expecting to detect when the agent was stuck and how long it would take him to get out of that stuck position. And then also, it was also a matter of simulation, the logging. So whatever amount of rewards he got was automatically uploaded into the simulation. So we had an Excel that it would automatically go into an Excel format where we'd have the number of steps that the agent took before he died, or how many, rewards he was able to get, and also what was the reason behind the termination of an episode. So in the first early training, we had a 20 episode setting where we had only one yielded a positive reward, which meant that in the rest of the 19 episodes, he was just moving randomly, no interaction with hazards. He did not know where he was going. He would get stuck and all that stuff. So at least we were able to, for the positive one, we were able to realize that the ledge proximity was exploited, that he was able to prove that the inverted reward logic was actually working. However, we had an issue where in one of the episodes, I think in episode 19, he had a very catastrophic failure in which that he got stuck to a point that just because once he got stuck, he realized that if he kept moving, he would still get more points because there was a reward system in which if he was moving forward, he was getting reward. So which we detected was actually now becoming a faulty reward logic. And then there was also poor exploration and flow tracking because he was just, once he got stuck, he just kept, he kept mark timing in the same position. So for the next episode, for the longer training, what we decided to do was that put a capping mechanism in such a way that if he was stuck for more than 60 seconds, he did not get any rewards, and we reset. And also the maximum steps that he was given for the episode was 300,000, which is a bit too long because so we decided to cap it into half in such a way that if he reached 150K steps, we would also reset. And if the stack logic, we also tried to fix it in the next training round. So in the extended training, the agent continued, like in the GIF below, we can see how the agent was able to now continue learning how to fall off the ledge. And anytime he fell off, we would have a new starting position, as you can see. And then it got to a point where he gets stuck. So he tries to turn left and right to get out of the position, and then it resets because it took too long. And then again, there's another time he gets more. It keeps each time he keeps learning how to navigate across the model. So the key contributions to this was that we were able to integrate 4D BIM with the game engine and create an RL pipeline. And also we successfully had an inverted reward logic. And also there was we created a custom sensor architecture code that was able to detect how many floors he had fallen off or how long he took in a stack position. So we were able to now be the findings was that the agent successfully learned to identify unsafe zones. So there was no pre-tagged hazards whatsoever. So he was supposed to figure it out by himself. So he learned that there was some, like in the point where he gets stuck in the column, he learns how to unstick himself from that position. So we were also, the RL training proved to be sensitive. So in the sense that, like I was talking about in the earlier episodes, in the episode 19, our reward structure was a bit off. So it was just giving him positive rewards, but in reality, he was not moving at all. So if I was to continue with this project in the next step, I would also learn how to clamp the reward shaping, to clamp how the reward shaping was created, and also maybe improve the zone discovery in such a way. Like one of the suggestions was that the agent would have been placed in a different building altogether so that he would be able to figure it out without having to learn the same route all over again. And also it was one of those situations where you were given an idea of maybe would have placed a barrier and see how he would have reacted towards the barrier when it came to warning signs of how if it was a hazardous zone. Also, in reality, it would also include, instead of having one agent, would have multiple agents. Yes, thank you.
Okay, thank you, Agnes. We don't have any questions in the YouTube, but maybe I can ask one question. What did you find to be the most challenging thing during the development of your work?
So initially, we had when I was working with my supervisor Manuel and also my tutor Bruno, we had set out that it would be like the work would have been divided into 3 phases, which would be equally 30% of the BIM, changing the BIM into the game engine, and then the game engine into reinforcement learning, and also writing of the thesis. But unfortunately, the changing of the BIM, or rather transforming the BIM model into the game engine, took way longer than we expected, which took more like 80% of my time. So the thesis was actually quite difficult to write because I was trying to catch up in time. That was my most difficult part of it.
Okay. And if you think about continuing this work, what would be your expectations?
Oh, I would prefer to have a longer duration rather than rushing it. Yeah, but I really enjoyed it.
It's really nice work.
Thank you.
So thank you for your contribution. I think we are a bit early on the schedule, but we'll move on. In fact, we don't have Pablo with us, so we might need to wait a little bit. Oh, I have one question, in fact, for you.
Okay.
From YouTube, from Sahish Wazir, what to find the best data for your research? Well, I don't know if it's exactly for you, but how to find the best data for your research paper when starting to write your paper?
I don't think I understand the question.
Yeah, well, I would say that's not toward you, but the data that you need to find, I think I can answer that. First thing you need, it's not about the data, it's about defining the subject that you want to study. And after you have the subject, you will start looking for if you can find data from online sources, if you can gather the data from other papers that are available, or if you need data from a company, something like this. So it depends. in your situation. So maybe we can wait a bit for me to contact Pablo, who is the next speaker, and we will move on. So give me a few more minutes and keep joining. Okay, so I'm back. I've just heard that Pablo is in Libruana. He's there, so I would invite him. Pablo Rojas will present to us the AI-driven assistant for level of information need in BIM workflows. Please share your screen and you can start your presentation. Hello, so I'm back. Due to the fact that what would be our second speaker, it's not available, we'll go directly to the third, but we'll follow the scheduled time, which is 3:20. So we will wait 20 minutes to carry on with the section. So please wait with us. Hello, everyone. We are back for our second presentation. Now we will start with Pablo Ignacio Rojas, speaking about AI-driven assistant for level of information need in BIM workflows. Please, Pablo, whenever you are ready, you can share your screen.
Well, are you looking? It is visible, the presentation screen?
Yes.
Perfect. Let's start with it. Hi, everybody. As it's mentioned, my name is Pablo Ignacio Camus, and I'm here to present my thesis named AI-driven assistant for level of information need in BIM workflows. In the current BIM framework, there is many developments introduced every year. This not only sets a challenge for trained BIM professionals, but also difficulties the access to the ones that are non-BIM specialists. In this context, the topic of this thesis aims to explore and test the possibilities of using AI in specific large language models to generate standard aligned documentation of level of information needed, a standard that's been officially added to the ISO BIM corpus on the last year. Right now, there's many tools on the market that allow us to define the levels of information need, but either they are form field based or their AI support is generic or platform based. In this context, rise the question, can we use large language models to retrieve stable and standard aligned responses to natural interactions? And can it be optimized to suit the level of information need? And by doing so, bridging the knowledge gap in between the AACO professional and the LOIN documentation and definition. To understand the purpose and the scope of the expected results from the large language model, we have to take a look on the ISO 7817, level of information need. The level of information need comes to redefine the previously used LOD, known as level of definition or level of detail, by eliminating the imprecise definition by number, lot 100, lot 200, and by replacing it, ensuring that the right information is delivered to the right people at the right time and for the right purpose. To do so, it requires 4 variables or prerequisites. That sets the context and allows to better define the information and the amount of information to elaborate for the intended use. These 4 things are the why, the when, the who, and what of the information that we need to define. From each of the objects defined by the purpose and milestone for a specific actor, we can elaborate the level of information need. This makes levels of information need a rather extensive and probably tedious labor to do, and it's why automating it or improving or improving its production with LLM could be profitable. The level of information need is a human and machine interpretable package of information formed by 3 information containers, geometrical, alphanumerical, and documentation. And each of them is decomposed in a specific definition, like detail, dimensionality, location, etc. All of this is important as it sets the elements to check on the LLM interaction and which the agent should be able to assimilate and elaborate on. To do so, we have to understand the tool that we're using. We know that LLMs work as giant statistical prediction machines. And even though they are great to perform different tasks, and they have set a revolution bringing the AI usage to the mainstream, they have their limitations. To mention some of them, like you can read them in the screen, limited long-term memory, bias in replies, privacy concern, etc. At first glance, its use for level of information need definition shows a good level of human-like interaction, but failed to respond with level of information need aligned documentation. This could be mainly because of the limitations on the knowledge that the LLM is being pre-trained on, triggering inaccuracies and bias response. In order to improve the quality, the stability, and the formatting, that is what we need to ensure a better documentation generation, many enhancement strategies can be utilized. In particular, the work developed through the thesis started from testing and trying to implement retrieval augmented generation and ontology alignment grounding to achieve the needed improvements. Throughout the development path of the prototypes, ontologies were left aside due to a constant step back on its implementation and set as one of the future development goals for this research. By doing so, the development focused on retrieval augmented generation, RAG, and the possibility of adding functionalities to refining. As the name itself says, retrieval augmented generation follows a three-step generative path. By retrieving chunks of information embedded on the model, augments the context awareness of the generative to the generative step of the LLM. This allowed to fill the information gap in between the pre-trained model and the up-to-date information. Improving as seen in the pre-evaluation, the quality and consistency of the interaction. As you can see in the graphic, there is a comparison in between the use of a local running LLM, in particular the DeepSeek R1 run through Olama, and GPT-5 Auto, compared to a GPT custom loaded with the same information and the retrieval augmented generation model. But as the information loaded to the model is solely contained the standards and stay in a theoretical knowledge ground, it struggled to request to generate object definitions. To improve this, new models were developed and added to the baseline RAG in order to improve it with broader information. Here's where the scope of the information was opened with a web search functionality, and to improve this, searching or rephrasing functionality was added on top of the query generation. This was in order to adapt the query that we use or the prompt that we use to retrieve something from an LLM to a standard question or query for a browser on the internet. To tackle the instability that then this added functionality generates to the response, a filter was added in order to ensure that the generative large language model always prioritizes the chunks of information retrieved from the vector database that contain the standard in case of incongruence. To improve the stability, then, of the reply and to make sure the quality of the response is good, a local deep search functionality was added. This local deep search functionality, different from like ChatGPT local deep search does, what it does is that it loops the same query over different rounds, by doing so impacting the stability of the answer and preventing deviations on it. As stated in the thesis, even though the results of these different strategies are promising, the true impact needs to be revisited, as they attempted to evaluate them, like adapting the developed prototype with Boolean doors was inconsistent. As stated before, during the development of the thesis, the implementation of ontologies as semantic alignment tool didn't work as expected, mainly because of two reasons, I believe so. First, the grounding methodology used was constrained, causing the LLM to restrict the interaction to the structure of the ontology. And second, that we lack of the development of a custom domain that aligned with the intended purpose. In order to assess the impact that the use of ontologies can have on the performance of the agent, it will be necessary to work over the existing ontologies or create our own to ensure that the domains, relationship, and definitions of the ontology are aligned with the level of information in its structure. On the other hand, we'll be interested to try the effect of the grounded method used in the generative, originally in the generative part of the retrieval augmented generation, on a validation phase in order to validate an already given answer, avoiding this problem of over-constraining the interaction between the LLM and the user. Overall, the pre-evaluation of the prototype outperformed a custom GPT loaded with the same documentation and instructed to ask as a level of information need assistant. The first graph shows the average compliance score on each of the evaluation criteria, and the second one shows the average variation score on the evaluation criteria, so less is more stable. Overall, the prototype improved on average 37% on the custom GPT and drastically improved the stability of the response over different runs on each of the evaluation criteria. Summarizing, the development of the prototype shows that it's possible to create a level of information need agent, but extensive testing needs to be done in order to define if it is reliable on a professional level. Till now, the tool shows reliable under the evaluation criteria, and the difficulty of its implementation is rather low. At the end, the results have been promising, and thanks for your time, guys.
Thank you, Pablo, for your presentation. I would ask if someone has questions, please send it to our YouTube chat in the live. And to begin, I will ask you a question. What do you think are the opportunities that arise from the creation of an agent as the one you are proposing?
Well, we actually discussed it in the defense of the thesis that the scope of the development of this prototype was to not only create the documentation necessary, that was one of the main goals set in the topic of this at first in the topic, but to be able to give a general understanding how the standards relate to each other. This model was not only loaded over time with the level of information need, but with different ISO standards that are related to the BIM framework. And its usability is intended not only for generating documentation, but as an agent that could help a user that either is not closely related to BIM, or as it's stated at the beginning of the presentation, it's needing to catch up with the new development on the standard. So I don't know if that answers the question, but yes.
Okay, thank you. Well, I've just heard for a third part that you could give us a live example of using your agent. Could you do that?
I cannot right now. I'm the computer of the university.
Okay.
But I would love to if maybe I can go from my computer and rejoin at the end. But yes, in the dissertation it was working and we play with it, and it's quite interesting. The only thing I can show you is the last slide.
Okay, it's the video.
Yeah.
Okay, so thank you, Pablo. That's a really nice presentation. And now we'll wait a bit for our next presentation that will start at 3:40.
Perfect. Thanks so much.
Thank you.
10h40, Paula quiser começar.
Yes. Hello, so we are back for our next presentation. Now we have Gabriela Galvão de Barba speaking about AI-driven system to support early age floor plan generation. Please, Gabriela, you have 15 minutes for your presentation. And if anyone has questions, please write it in the chat in the YouTube. Thank you. You can start.
Okay, can you see my screen?
Yes.
Okay, perfect. So my name is Gabriela, and my master thesis is an AI-driven system to support early-stage floor plan generation, and it was supervised by Bruno Figueiredo, Felipe Brandão, and João Silva, my tutoring company. So, as we know, in the beginning of
Gabriela,
Yeah.
I'm sorry. Could you put your presentation in full screen? You are sharing the other screen.
Mhm.
Okay, how was the like? How did I? Oh, here. This is share. You have to share screen. Thanks.
Now it's full screen.
Now I don't see, just see the background for.
Now I think, yeah. Now?
Yes, now it's good. Thank you. You can start.
Thank you. So, as we know, in the beginning of a project, as architects and engineers, we have to consider a lot of things, such as client needs, municipal regulations, and also environment constraints. So, managing all these can be really complex and challenging. Besides that, if you leave those things to be managed just in a late stage of a project, can be time consuming and really costly. So it's better to have like an automation system to increase the efficiency, reduce the human error, and also be possible to explore more design options. So this is what the AI-driven system can do. From a simplest prompt, using natural language, we can generate early stage floor plan. So just a little bit of context. Computational design is kind of umbrella concept that covers parametric design, generative design, and also algorithm design. And parametric design is a design process based on algorithms thinking that uses rules and parameters to improve constraints. Generative design is a design process where algorithms automatically generate multiple solutions based on rules. And algorithm designs use algorithms to produce models, and it is considered as a subset of generative design. Here we have like a illustration diagram made by Caetano that illustrates the relationship between those. So, a large language model is a language system based on neural networks that is trained in massive tests, contain billions of parameters in very large data set, convert test flow instructions into structured output, and genetic algorithms use a problem-solving approach to find outcome solution. Algorithms are often integrated to generative design tools such as Grasshopper and Dynamo to address optimization challenges. And the use of genetic algorithms has increased a lot in the last researches. And the use of PD in architecture enables simulations in early design stage, supporting rapid interaction and creative exploration, improves design making, reduces manual work, and ensure accuracy and integrate performance criteria. Here we have some examples about the research in the field. So we have architects that use LLMs and Grasshopper for floor plan generation. It's easy to use and open source, has a limitation related to no circulation logic and daylight analysis. The data structure design use a structured data in JSON format with an LLM and control area. It's possible to control areas and adjacency. The issues is sometimes the overlapping and they struggle with complex inputs. And we have the floor plan generation using hypergraphs, that is a hypergraph model for spatial relationship, optimize daylight and environment comfort, and has a limitation related to focus on, because it's just focused in single apartment layouts. So with those example, we can see that we don't have any tool that manage the municipal constraints, client needs, and environment constraints all together. So this is what the system will allow to do. So it is divided in 5 phases. In the first phase, we have the user input that's called for LLM. So when it's called for the LLM, it searches for semantics like types, area, connects to, and Windows count. Then it populates a structured data to export a JSON information. So the phase 2 is this JSON output. Then we go to the phase 3 that came from the JSON output into Rhino Grasshopper to generate the floor plan options using also the parameters. Then we go to phase 4, that is the validation process that get those floor plans, and also information related to the terrain that the building is, the terrain in the city, for example, Guimarães or Ljubljana. So we have a terrain, we apply the setbacks, then after the setback, we apply a grid and get the points of the intersection of those points. And each point stores some information such as coordinates, noise level, distance to the axle of the street, and those kind of things. Then we finally go to the phase 5, that is the visual output. So we would have like an interface that has the chat input in the left and the visual output in the right with the floor plan zoning, and floor plan graph, and also some general information. So to develop all this, we use a few environments, a few tools that was Rhinoceros, Grasshopper, Ladybug, and Magnetized floor plan generation plugin, Visual Studio Code, Python, JSON format, and Excel and ArcGIS. So from the input, we get from the test that the user put, we convert it to a machine readable format that is JSON. Then we go with those parameters for code A and code B. So code A is responsible for the floor plan generation. So we have some parameters like area, rooms, connectivity, windows count, noise level, sun hours, amount of sun hours during the summer and the winter, and the requested area. So from area, rooms, and connectivity, we go to the magnetized floor plan that generates options, base option, the script. And we also have a slider that we can manipulate those options that goes from 0 to 400. After that, we generate the floor plan elements such as walls, doors, and windows. We also apply the legend of the room, the coloring, and the graph map to finally have the final option of 400 final option of floor plans that can be seen in Rhinoceros in 3D and 2D, and we also can export it to ArcGIS. And after that, we also go to the validation process. But we still have the code B that get information about the site, such as building type, location, and site dimensions. From the site dimensions, we get the site limits, apply the setback, the grid system, and then the points get the coordinate, noise level, and the amount of sun during the summer and during the winter. So for noise level, we create a rule that is according, if the point is close to the axle of the street, it's a high level of noise, and is it far, it has a low level. And for the sun analysis, we use Ladybug for this analysis, and we also manually input the surrounding area of the terrain. So then with code A and code B, we go to the validation process that get all those parameters, export them into a JSON file. Then using Python, Visual Studio Code, we converted it to a Excel, and this Excel passed through a validation process using VBA that is shown in this table. The red mark is that those things that do not comply with the requested, and just the ones that are fully approved has the green label of approval, the green status. So for the case study, it was shows a terrain located in Guimarães, Portugal, that is located in a transitional area between historical center It's a residential and commercial and also service functions. The dimension is 25 for 30 meters. In there, the municipality constraints is that the setbacks in the front is 3 meters, in the side and back is 5 meters. The maximum height is 7 meters, and the building coverage ratio is 70%, and permeable area is 50% of outdoor space. So for this, we generated 3 different prompts. Each one has 400 layout options, and only the ones that meet all the criteria are approved. So for the first prompt, we have in the top the user prompt that describes what he wants, and this image that is changing are the approved options. So for this case, we have a maximum area of 150 meters squared. The client said that the bedroom and the office should be in quiet area. He also said the toilet, corridor, and bathrooms don't have any windows, just the other rooms. And for the sun hour during the winter, he would like to have 3 hours in the living room. So we got 12 layout options in this simulation, and if we analyze the graph, we can see that the rate we had a really low rate of improvement in noise level because it was hard for the system to meet the requirements related to the position of the room according to the points that store this information. But we also had a good result in area and sun hour category. For the second prompt, we have 100 meters square of maximum area, and we have some new rooms that are art studio and library. Those two and also the bedroom should be located in quiet area. The sun hour in the winter would be 4 hours in the studio and 2 hours in the bedroom. And all rooms should have at least one window, except by the corridor. So with this prompt, we got 5 layout options that were approved. We can see again that the lowest rate was in noise level category. And we got a good result in room category and sun hour. For the third prompt, we have a maximum area of 125 meters squared. There's no requirement related to noise level. So, but we have a specific requirement related that the user wants to have 2 windows in the living room and no windows in the corridor and toilet. So from this prompt, we got 3 layout options that were approved by the simulation. And if we analyze the categories, we can see that the lowest rate was in the windows. That probably it was because of those 2 windows in the living room that was hard for the system to meet. But we can see that he made it. And it had a good rate in area, rooms, noise level, and sun hours. So if we analyze all those 3 studies, we have a strong performance in area, rooms, sun hours, and access area category. And the weakest aspect would be the windows, noise level, and architectural elements generation. So we can conclude that restrictive prompts reduce approval rates but increase compliance, and human intervention remains essential for further development. So the contribution of this work was that we have now an AI workflow that connects natural language, parametric modeling, and rule-based validation. The results in multiple layouts alternatives generated for each prompt. It was really big. It integrates client's needs, municipal regulation, and environment constraints. From abstract, we can have visual alternatives that are ready for the next stage of a project. We can save time in early stage design and focus on creativity. It supports exploration and raise efficiency and decision making, and demonstrate the potential of AI as a co-creative partner, not a replacement for architects. So future works in the field would be improve the control of the architectural elements that sometimes crash when we run the system, allow the setting of windows and door location and size, allow more than 4 rooms connect to one single room, allow editing a specific element in the layout option instead of replacing all the layouts, include the volumetry of the layout option in the cell analysis that is not being considered in this study, automate the input of the municipal constraints that was manually input, develop a user interface, test in other case studies and expand to multi-unit apartment, and advanced BIM integration with IFC model export. Thank you.
Thank you, Gabriela, for your presentation. It's a really nice work and really well illustrated. I will open the floor for questions. We still don't have any questions in the chat, but I would like to ask a philosophical question, if I may. What do you think? What are your thoughts when you think about this type of tools, like AI-driven tool, and maintaining, ensuring that you keep like creativity and design diversity while using these tools?
As I said, this tool is not to replace architects, it's just to help, because I believe that this tool or something similar can help us to connect the things that we took a lot of time to make it, like how I'm going to connect this room to the other room. I want to have sun in this room. So the system would like thinking about the logic part of this floor plan. And the architect still have like the knowledge and the power of changing and choosing between the options that the system said that is approved, and changing what he thinks should be changed. And as for now, it's just like, for example, 2D floor plan, and from this floor plan, the architects still have to do a lot of job for the next stage, like the architecture, the elements, 3D version, all those things are going to be delivered by the architects and created by the architects.
You'll be focusing your energy in other aspects instead of only the logical constraints.
Yeah. Mm-hmm. Yeah.
Okay, so we also have one question from YouTube. What logic did you use to disjoint outer walls from interior partitioning walls? To apply different material layers, for instance?
No, I didn't went to so deep. Like I don't have material.
Okay.
Like for example, generic wall, generic floor, and from this, the architect should manage it.
Okay, so in fact, you won't define like the perimeter of the rooms and the construction, and the rest, it's up to the architect. Is that
Yeah.
it?
Mm-hmm. Yeah.
Okay, so thank you very much for your presentation.
Thank you.
I think we can move on. The next presentation starts at 4, so we have 2 minutes. I think it's enough time for the next presenter to prepare. Up next, we have Eddie Alberto Jimenez with practical augmented reality for modular construction, a BIM driving factory to site workflow. Please, Eddie, when you are available, you can start sharing your presentation. And
Sorry.
Eddie, we could see your screen for a few moments, but now we can't.
Yeah, just give me a second. Okay, can you see it now?
Yes, now it's perfect.
Perfect.
You can start.
Good afternoon. I'm gonna present my final test work for the dissertation, that is practical augmented reality for modular construction, being right factory to site workflow. I'm in Mendoza. I'm gonna follow this. So that presentation is gonna be divided in 5 sections. The first one is the introduction. Second one is concepts and findings. Third one is the creation of the framework. Fourth is the implementation of those frameworks. And finally, the considerations. So the introduction, currently the construction, architecture, engineering industries are facing a transformation from traditional methodologies to digital methodologies. This would include like optimization, AI, augmented reality, virtual reality, mixed reality, and other implementation. So that needs that transformation is because the need of having the information accessible all the time, especially on mobile phone. So this is when augmented reality is come to the context as a possible solution to have that information accessible. So the dissertation basically have like a 4 objectives. The first one was to evaluate the current landscape of the AR into the BIM methodology. The second one was establish or create a framework from the integration of BIM and AR. While the third one is to define the user experience interface for this integration. And the last objective was to demonstrate the viability of the proposed system or tool that we will see later. So the second section is concept and findings. So during the literature review, basically we discovered like the 3 lines during the investigation. The first one, all the application of AR in construction. The other one was the implementation of the synergy between BIM and AR. And finally, the gamification of BIM and AR. The gamification is the application of game design principles into a no-game context. Context like education, marketing, construction, transportation, etc. So it's important to say that this transformation in the industry currently is relied on the extended reality environments due to the popularity these environments gained in the last couple of years. So to define what is extended reality is basically the concept that integrates contains augmented reality and mixed reality and virtual reality, where augmented reality is the juxtaposition of digital and real world elements, and virtual reality is the mix between the physical and digital content, while virtual reality is just an totally immersive experience for the user. So meaning that everything is digital. There is no interaction with real elements. So one of the advantages that augmented reality gives us is to be able to understand the complexity of geometric information, because you can see the things in the computer, but it's not the same as experience with your eyes and with your view and stuff like that. So now why AR? AR basically provides us guidelines for new coworkers. Give us the productivity increases. Detection of potential safety and risk, especially this one was of the most common uses right now. increase on sustainability and profitability, and the real power defect detection. So the other line that was discovered was the synergy between BIM and AR. It's important to say that BIM is like a mental exchange from 2 dimensions to 3 dimensions, where the AR implementation is important that define that AR give us like a normally you have when you use the computer and you design, you have a monocular way to have the information. You just only see it on the screen, while AR give us like a 2 ways or binocular implementations. Well, we receive the information from the real world and from a screen. Other disadvantages or challenges about AR is the human factor, because for the resistant to change or to unexperienced professional does not have like any practical knowledge of the industry. The contribution, being an AR contribution, can be focused on education and training, user experience, transferable knowledge, especially for user-friendly interfaces. That we will see later that it was one of the main milestones in the integration of BIM and AR. So as we discussed before, the gamification concept is the implementation of game design principles into no-game context. And this is why AR, in general, all the extended reality has been like a really integrated or have gained popularity in the industry because of all the previous implementations that have been in the entertainment industry. One of the things that is important to emphasize here is that this integration, we have to take into consideration the type of files we are gonna be changing from game engines or for programs, the level of complex that information we need, especially we have here the LOIN as previous presentation explained. But the most important for augmented reality is gonna be the level of geometry granularity that is like LGG, because it's like a more complex context that can capture all the geometrical information. So the framework creation, for this framework creation, we did like a several steps. That it was the game engine evaluation, Unity versus Unreal, Unity implementation, framework, the creation of the augmented reality framework, and finally the creation of the user interface framework. So during all that, we evaluate 8 game engines for the implementation of augmented reality. At the end, we have like a three ones that could be like a solution, a possible solution: God, Unity, and Unreal. But as God didn't have like that popularity as Unreal or Unity, we decided to just keep it the next step only to Unity and Unreal. At the end, we choose Unity because of the cost is basically free. Learnability is more easy to learn, and provides like a cross-platform support, meaning that it can work with iOS, with Android, with Lens, and web-based. Because Unity is more popular, so it has like a more resources to find in the web. Because the programming language is a little bit easier than Unreal. So this is how the framework was created. It was divided in 4 stages. The first one was the initial decisions, then the formatting setting, and the third one was the metadata setting, meaning if we will need metadata or we will need it or not. Because this decision is gonna be essential for the next steps. The last section was the AR setting that we basically just decided which methodology we're gonna use. So here we have like the tool developed was focused on only for Android devices. And we use the GLTS format because the tool is connected to an API that is currently being built. So it will require the models to be downloaded from an API. So GLTS format was the most easy and the most open source solution at that point. Then we just decide for our case, we didn't need too much metadata. We just need like some specific points, and then we just choose the AR foundations by Unity. We choose here the AR plane because it wasn't like a more stable solution. Then for the user interface framework, it was based on a framework created for Franklin Hernandez Castro on the usability book, Metodologías para el análisis de investigación de aplicaciones, that this was created in 2017. However, this is the Hernandez Castro framework. In our case, we modified that framework, especially in the stages 4, 6, 7, 8, and 9. This framework is like a 12 steps that divides the user interface design in several steps. And then the implementation of the frameworks, basically for the implementation, it's important to notice that due to time limitations and resources, we couldn't implement all the framework, but the framework was implemented just from the from the stage 1 until the 9. Based on the AR framework creation, for each section was divided was assigned a function that the tool was being compliant. So for the first one was authentication. Second one was the GLTS formatting, and then the metadata grouping, and then the is scene management and model manipulation. So for the first authentication function, we use Docker, C script, the API connection, and the Unity or the device. For the converter metadata functions, it was used Python script with the IFC OpenShell to convert the original IFC file from a GLTF, and then we use the GLTF extract to incorporate some metadata. The model manipulation, basically we create the app that it was called AR assembly to divide the general like a user interface with the BIM AR interface. We did this operation basically to optimize the functionality and to both user interface no crash together. So this is how it looks the app at the moment. It's important to mention that as the app needs a connection to an external API, it was not possible to test all the functionalities of the application. This is more or less how is look the app with the general. In the left, you have the general user interface, and in the left, you will have a few screenshots of how it was supposed to work. It's important to mention that the metadata was used to divide the model in 8 groups, which those groups were going to track the progress for the construction, because this thesis was focused for the construction of prefabricated elements. So we will took like 8 groups, walls, floors, roof, furniture, the finishing of the model. We divide those into 8 groups to track the progress of the construction process. So some considerations is that even though we try to settle or create a path for the BIM for the BIM AR UI design, it was impossible because this is not something that is static. It's always changing. It will always depend of what the project will require. It will require metadata or not. It will require like a general user interface or not. So the thesis was successfully fulfilled as we were able to test the tool created. Other future implementation development could be then the full implementation of the reporting and the tracking logic, the cross-platform development to try to translate this into the iOS or other devices. Expanded the user testing because the testing was only performed with a few colleagues from the master. And IFC or IDS validator integration, advanced interaction model like voice commands or similars. That's it. Thank you.
Thank you, Eddie, for the nice presentation. I will once again ask people, if you want to ask a question, please send in the chat in YouTube, but be quick because there are some questions that are arriving after the presentation and the speaker are already dismissed. But I will start with a question. What do you think are the biggest challenges regarding like the organization and the human aspect of adopting augmented reality in modular construction, for example, to put this type of tool into practice?
Actually, that was a really big concern during the development of the project, because all the literature review was focusing on that currently, as the construction workers are getting like a certain age, that they are always like have like this restraint to change. It's a complete challenge to do this implementation. That's why there were some proposals to like create like a game with the use of AR, like make it in a fun way, like with rewards or things like that. So it definitely is a challenge, but it's something that can be manageable during doing a smart implementation, not just a general implementation of giving the previous training to the workers.
Okay, so considering that I don't have any other questions, I will thank you once again for your participation, and I will close this section now. I would like to thank all the audience and everyone that was present during this session. The next session will start at 4:40 Central European time. So we have a 20 minutes coffee break. So please stay tuned with us, and we'll be back in a few. Thank you.
Okay, we are exactly on time. Welcome back to the BIM Plus conference. In this afternoon session, we are covering some exciting topics related to BIM data, to parametric design, to quality control. So yeah, let's try to turn this session as much as possible in a dynamic environment. So I invite you all to share your comments, your thoughts at the YouTube channel. Yeah, so feel free to, whenever something pop-ups at your mind, anything is relevant. So I would like first of all invite Ezra Karatepe. I hope I didn't mispronounce your name, Ezra. So
It was perfect.
So you have 15 minutes to present your dissertation and then +5 for questions from the audience. So good luck. And whenever you are comfortable, the floor is yours.
Okay. Can you see the presentation?
Yeah, just okay, please. Okay, is in
It is full screen, right?
is exactly, yeah. It's right.
Okay. If there's no problem about my voice, I'm starting.
Okay.
Okay, thank you. Good afternoon, everyone. Thank you for attending this conference. And the dissertation presented here is titled Standardizing Information Requirements for BIM-based QA/QC, a contractor-oriented approach. The research was carried out under the supervision of Professor Jose Carlos Lino with company tutors Miquel Bienes and Bianca Fontana at Basics. The study addresses one of the most persistent challenges in BIM-based quality management, the lack of standardization and verifiability in information requirements. And before delving into the details, here is the structure of the presentation, and you can also follow it at the bottom part of each slide. Current practice shows 3 main problems on Basics end: difficulty in collecting information, time lost filtering what is relevant, and repeated efforts across projects. The consequences include delays in project setup, increased risk, and inconsistencies in meeting client requirements. To address this, the research focused on designing a structured, modular, and adaptable EIR template that integrates QA/QC and enables the transition to machine-readable ideas. The motivation lies in transforming the EIR into a strategic instrument that not only supports contracts, but also strengthens QA/QC outcomes. Here we can check the methodology. The research followed a structured four-phase methodology as illustrated in the diagram. Phase 1 focused on academic sources, industry standards such as ISO 19650 and contractor practices. They were reviewed to establish a foundation, and the objective was to capture both theoretical perspective and practical gaps in the information requirement management. In the second phase, existing EIR templates from different international contexts were examined. This allowed the identification of best practices, common shortcomings, and the information blocks for a structured template. In the third phase, insights from the phase 2 were used to design a contractor-oriented EIR template, and selected EIR clauses were translated into IDS rules, creating an EIR IDS pair that supports both human-readable and machine-readable requirements. In the last phase, the framework was tested in practice through a pilot project. An IDS file was created and validated against an IFC model. This is complemented by qualitative data feedback gathered through a survey at Basics. As shown in the diagram, the methodology forms a cycle that combines theory, development, application, and validation. In this way, the research was grounded in an academic literature, while remaining practical and relevant to industry. When we move to the second chapter, it is the literature review phase, and according to ISO 9000, quality assurance is the process-oriented dimension of quality management, integrating preventative activities into workflows. On the other side, quality control is the product-oriented dimension of it, relying on inspections and verification at key milestones before handover. And the traditional QA/QC model is heavily depends on manual documentation inspections. BIM has progressed from 3D modeling to a full lifecycle information management process and became increasingly mandated since 2000s. And this growth created a stronger need for reliable, verifiable information in the industry. As a result, QAQC shifted from isolated inspections to being embedded in digital workflows, making it proactive and continuous rather than being a reactive tool. And when we move to EIR and IDS, the EIR defines what information is needed, in which format, and by whom and when. It includes technical, management, and commercial dimensions, and properly defined EIR also allows early rule checking information. On the other hand, IDS translates those requirements into a machine-readable XML structure aligned with IFC and BSDD. This enables automated model validation, ensuring consistency, traceability, and auditability. Nevertheless, challenges persist in the industry. EIR often lacks precise definition, IDS tools remain immature, and misalignments between stakeholders and software environments are frequent. After the literature review process, 5 meetings at Basics headquarters in Brussels are held with BIM managers and coordinators that revealed 3 key points, which were the absence of standardized, reusable QAQC frameworks, the need to balance technical solutions with practical usability, and the strong potential of IDS to provide structured, machine-readable requirements. And these findings directly influence the scope of the proposed EIR template and the integration of IDS. Here, the guiding principle behind the proposed EIR template by comparing current EIRs with a structured EIR approach. While current EIRs are often too generic or overly detailed, which creates ambiguity, a structured EIR instead standardizes information blocks, ensuring clarity. And deliverables in current EIRs are frequently unclear or redundant, and a structured EIR template aligns these requirements with ISO 19650 workflows, improving consistency. Traditional EIRs often cause misalignments in QAQC's responsibilities. In contrast, a structured EIR reduces misinterpretation by clearly defining requirements. And finally, the current EIRs are generally not reusable across projects, while the structured EIR promotes reusability and organizational learning. After these steps, before moving into creating an EIR template, 8 international references were reviewed, and 5 were selected as the most influential ones to shape the structure of the EIR template. First one was the Building Smart Portugal EIR template, which is recognized for its strong alignment with ISO 19650, and it provided rigorous technical structure for modeling rules and LOIN and naming conventions. In the second one, CIC BIM EIR template, it demonstrated a clear modular design and highlighted the importance of the adaptability of an EIR template. With the Kiwi Rail New Zealand EIR template, there was a strong emphasis on the asset management and CDE workflows, which helped to understand the project and asset level information requirements in the template. With the fourth one, New Zealand BIM Handbook, this is the national endorsed guide that includes RACI matrices, validation requirements, and structured process definitions. And it informs, it helped to prepare the management layer of the template. With the last one, which is UCL Estates UK EIR template, this has helped to embed the COBI deliverables, KPIs, and operational data requirements, and to understand the importance of EIR for the life cycle of the project. Drawing from these examples, Basics EIR template was structured around 4 modular layers: technical, management, commercial, training, capability, with the subchapters that can be seen here. And together, they formed a balanced foundation for contractor-oriented EIR template that is modular, adaptable, ISO 19650 and basic standards aligned. On the right side, the structure of the template is shown. It begins with the introduction and continues with the subchapters, and then ends with the training and the competency requirements. And on the, on the left side, the EIR pyramid illustrates how the template is positioned as more than a planning document. It is first ensures the structured validation, then defines responsibilities and quality gates, links to external standards, and ultimately transforms the EIR into actionable QAQC tool that integrate with IDS. Here it can be seen that the chapters shown from the EAR template created, as mentioned on the previous slides, 8 chapters color-coded according to their discipline. And the framework was applied to a pilot project following the creation of the EAR template. The initial test, the pilot project was chosen as a hotel model, which was comprised of thousands of architectural, structural, and mechanical elements. So to downsize the scale of the project, it has been decided to move forward with only one layer, and specifically with an architectural element on that layer to control the validation process more professionally. But before moving into the details of the model validation, we can see the context and description of the case study here. The aim of the case study was to translate EAR to IDS, and of course validate the IFC model across IDS file. And after that, first the existing IDS templates were tried to be used to create one for the pilot project, but after that it has been found inefficient, and then at that moment it was time to find a tool that can be used to create an IDS from scratch. And at that moment, BIM IDS editor has been chosen as the tool because it was user-friendly and didn't require any software knowledge. And at the 4th stage, the sources were pilot project and basic standards. So the requirements were organized in LOIN templates, combining project-specific needs with company standards, and structured clauses such as here you can see thermal transmittance are turned into the IDS version of the information. And while narrative requirements such as meeting obligations remained outside of IDS, and they were kept in BEP and QA protocols generally. And the validation process began with wall elements in the basement floor. A total of here you can see the walls at the basement floor, and a total of 163 wall elements against 8 IDS requirements were checked, and in total 3,704 checks were performed. And as an outcome, it was 100% compliance, which means that all requirements that were embedded into IDS file was existing in the IFC model, in the wall elements of the IFC model. And after that, the validation process was followed with the qualitative data collection feedback from the company basics. To refine the framework, a survey has created and shared with 13 BIM managers and coordinators in the company, and only 6 responses are gathered. And the survey responses confirmed strengths in structure and usability, but also highlighted readability issues due to abbreviations, the need for diagram, and calls for dashboard style tools. And these findings demonstrated that the value of the template, but also highlighted need for further adaptation, localization, and digital transformation. Here it can be seen that out of 5, in general, the ratings were around 4 for the 3 questions that are asked to coordinators and managers for the ease of use, alignment with process, and recommendation of the template in the company, which can be seen as a positive feedback. And more, there were some suggestions to create a dashboard-oriented version of it to keep the file up to date. Also, like translate a part of EAR to have an NL template to represent the local standards on their end. Even if tables and rows were straight format, they were be considered as a little bit too open. That would create some interpretations on their end because of having an open-ended questions. And one other suggestion was that one other comment was it can serve as a contractual addendum for the procurement consultations, and they found the document well structured, easy to understand. Moving with the conclusion, this research addresses the lack of standardization and verifiability in BIM-based QA/QC by designing a structured modular EAR template tailored for contractors.
demonstrating how AR clauses can be translated into ideas for automated validation, and collecting feedback from industry stakeholders to confirm the practical relevance of it. Limitations include its application within a single contractor context, and narrow ideas coverage limited only with the architectural goals, and the inability of the ideas to handle narrative and process-oriented clauses. On the key takeaway side, the research provides a structured, practical, and forward-looking framework that supports the industry's transition towards scalable, verifiable, and interoperable QA/QC workflows, with relevance extending beyond basics to wider construction sector. And in the future directions, it includes expanding ideas to other disciplines such as structure, MEP, and integrating EAR into dashboard and CD platforms would be something to do, and exploring AI and NLP for requirement parsing, and the institutionalization of EAR to ideas workflow at the organizational level can be seen as the future directions. Here are some of the most used valuable references represented. Thank you for your time and attention.
Well done, Ezra. Quite an important topic, although sometimes neglected, especially when it comes to BIM workflows, but I do believe you sort of bridge the gap between quality control and information requirements. So congratulations, your work
Thank
is
you.
fantastic. We still have some time for questions. We still don't have any, we haven't received any questions in YouTube, but I could warm up with one. So, okay, so I've seen that you use some EIR templates and even one from Building Smart Portugal, and I'd like to know, did you have any troubles or problems interpreting those templates, or even in a broad sense, interpreting ISO 19650, especially part 2, that I do believe that you use it, and in terms of abbreviations or new terms that are not so, spread out in the industry? How did you manage this?
To be honest, since I haven't worked with any EIR or IDS before, it was a bit, ambiguity for me too at the beginning while I was trying to understand those EIR samples. Some of them were really focused on a specific type of project, for example, a railway project, and which was really valuable to understand the structure, but these detailed sides of the templates that were only project specific were not the parts that I actually take reference from. So I really tried to understand the general concept and the common things in between those EIR templates to really make something more like really useful and future-proof, let's say, rather than making something project specific. But also like the ISO 19650, it was really challenging to read and like to understand how to use and how to integrate it. But of course, in the process, it was a bit like a time-taking process, I would say. But still, like even if I was not really understandable some parts of the AR templates fully because it were so company or project specific, I really took the benefit of the common sections or like the logic of creating it in general. And that's why they were really valuable in the process of creating AR templates. I cannot hear you, Andre. Like, yeah, your speaker is...
Okay, sorry, I was
okay.
So fantastic. Thank you for this explanation. I do believe we don't have any longer time. So thanks so much, Ezra. Good luck in our future steps.
Thank you.
Whether applying that in the industry or in the academic field. So yeah.
Thank you so much.
Thank you. So now we are moving to the next BIM Plus student, which is, if I'm not mistaken, Brian Wilson. So Brian, if you're online, please turn your cam on.
Yeah. Hope my screen is visible. Am I audible?
Yeah, just please put your screen on the full mode.
Yeah. All good?
Okay, we are exactly on time. So whenever you feel comfortable, the stage is yours.
Okay. Okay. So, hi guys. My topic is on the value of BIM for owners in the asset management stages. So we go on to just a moment. I think I'm having some trouble moving the slide. Okay, sorry for that. What is asset management and facility management? So it is basically the costliest phase of a life cycle of a building, which an owner has to implement and invest in. So the problem that I'm facing, I'm focusing on is the handover issues and the uneven data transfer and the time waste during this phase and what comes off it. So the aim was to show how BIM brings value to the facilities management stages during its operations and how to measure it in a simple terms. So here you can see what the different types of investments from owners in construction or life cycle of a building. So the acquisition, commissioning, operation, maintenance, production, etc., are huge investments from the owner side, which comes into the building life cycle, of which majority or 2/3 of it can go into just the facilities management stages. So then we go into a study in the industry research, which is already in place, which is the current stages of facilities management without the use of BIM. Then we layer the study into 3 categories on studying the current state of BIM, how BIM brings some optimization to FM, and the added benefit of BIM into the industry of facilities management. So here you can see the different problems which you can face during implementation of a proper FM strategy or a BIM strategy within an organization of a facilities manager company or any BIM related firm. So people are the first problematic area on how they adopt to a new change, and then there are changes of difficulty of adoption to new strategies, enabling BIM methodology workload, and so on. So this resistance is a huge study which was coming repeatedly on industry research. So then another study which we came as we try to understand is the type of BIM maturity and maintenance strategies within the industry, which is basically reactive, preventive, and predictive. What is reactive is the type of attention which we give to assets on the stage where it runs to failure, and preventive is a scheduled asset strategy where we can keep a scheduled recurring time based of assessing the asset until before any major failures or damages to the asset is happening. And predictive is when you have proper analyzed data structures which we use with LLMs and things to actually analyze the assets before it starts to go into any strain or troubles. Here you can see the evolution of a BIM model into the digital twins by the integration of step-by-step integration of simulation, sensors, and AI to finally bring in the life of digital twins. So then we wanted to get a better understanding within the industry on how it is actually implemented. And this was done by 12 interviews of professionals within the industry of EU, US, UK, and Singapore. So a common type of questionnaires was prepared for this kind of interview so that we could get common drawbacks and benefits within the industry of the facilities management side. And here we see the different types of approach of how the interviews and the data gatherings which was taken away from them. So what are the actual problems faced by the industry. So main problem which was coming repeatedly from these kind of industry experts was the interoperability and integration issue of BIM, which is a new thing which earlier facilities management was just done by spreadsheets and basic things like that. And then the knowledge gap and awareness of how BIM is to be adopted, usability and training within the organization, and the standardization and handover within the organization, and of course the financial problems of the owners and how they must invest in it. So what are the three, there are three maintenance strategies which we earlier came across, and here you can see how the professionals within the industry have used the strategies to focus on the facilities management strategy for their company. So you can see the predictive maintenance is the least, but everybody is trying to aim to achieve that thing, that kind of methodology. But for predictive to be in place, there should be a proper preventive management stage already set up within a facility management project. So from the literature study and the interviews, we come to common barriers which we are going to which I had implemented into a case study to figure out how to overcome these problems in real life. So main things that again came up was the information fragmentation, manual data transfer, cultural resistance, lack of user engagement, and unclear roles within the organization. So how do we implement a proper FM strategy with the use of BIM? So obviously, an early implementation of BIM in the early stages can actually help how the FM strategies in the later stages can go. So the data transfers and the data handovers, the file requirements, the asset information requirements, all those things do actually matter. So from open BIM standards, you can derive IFC, IDS, and building collaboration formats to create a proper asset information model, which then can be bought into a facilities management platform to properly do the facilities management strategy. Here you can see the case study which I have selected, which was done along with the Limson, which is the co-partners of BIM A Plus, as well as my thesis mentors. So I chose their project and a small pilot block of the building, which is the whole campus is of 50,000 meter square. And the priorities was given to what kind of assets were actually monitored for the facilities management strategy. So here you can see the filtration and the process of how the IFC and COBE data sheets from the Revit files and the 3 BIM models was taken and then filtered the required assets and prioritized them to then finalize the facilities management strategy. So for the case study, we selected the scene assets specifically, which was we chose them based on their risks and how effective it can be to bring down the cost of maintenance. And the main strategy followed for this was preventive, because that was the takeaway from the industry interviews and reviews, literature reviews. So we take the study into and assets into consideration, and then bring it onto the facilities management platform, which in my case was the Dalux FM platform. And straight away, by use proper filtration of these assets, we avoid the unwanted data handover or the transfer from the BIM model. Actually, the BIM model or the IFC model can contain a lot of unwanted data, which is not actually required for the facilities management stages. So by the proper assessing and filtration of these kinds of assets and targeting specific assets like we saw earlier, we can actually shrink our target and focus to bring out a better facilities management strategy. So by registering these assets onto the Dalux FM platform, we can create QR codes individually for each of these assets. And this in turn can also target the helpfulness of facilities managers on the site who can access the assets through the QR code scanned while walking through the facility or the project, basically. And this helps people to locate and target the asset which is actually supposed to be maintained. So by this, what actually improved by using this implementation of a proper facilities management strategy? So by the proper implementation of a organized workflow and proper data specification, we saved over 20 minutes per work order. That is 20 minutes per asset. So we analyzed and formulated a calculation where owners or facilities managers can use to assume or calculate a savings pattern for their a single asset within their yearly asset management. So two types of facility management calculations have been done during the thesis. Here you can see the work orders and the time saved and the time saved during a year. So 20 minutes is almost 0.33 hours. So assuming that there are 2,400 work orders per month and 45 euros per employee per month per hour, we can assume that there is over 35,000 euros of savings just from an asset. So this case study also supports the life extension and energy opportunities of these as opportunities from a proper facilities management structure. So the final thing is to keep in mind is having a proper FM strategy with a proper asset information requirement and a level of information need in the early stages with proper KPIs, which actually help in scaling the portfolios and projects in the later stages. And always it's the people's mentalities that is greater than the technological incorporations into an organization, along with proper training and governance. So BIM actually does create the value for owners in the operation stage, and it can be a proper FM backbone, but not just a static model. And this actually shows how practical measurable gains today can be help for a predictive tomorrow. Thank you.
Thank you, Brian. Amazing work. Well done, first of all. Let me check if we have any questions, but I don't see any at the chat. So not yet, but maybe I can ask you a couple of questions because we still have some time. So first of all, amazing work. You have covered a topic that is not well spread, maybe on the BIM methodology, which is like how to apply the technology in other phases that other than the design and construction phase, which is great, even covering Kobe. And I also realized that you somehow continued a work that has previously started by another BIM Plus student at the same company, Vincent. So yeah, my question would be, I don't know, maybe if you have any input or maybe if you have any insight from the past work that has developed before, in a sense of elaborating your KPIs or even maybe creating a metric key to measure the return of investments to the owners. So how did you have any input from past works?
Okay, so two things which you have said was the earlier. This is actually a continuation from one of the previous studies, which is the value of BIM for owners in building and construction phases stages. So that actually is in the building life cycle terms is actually part earlier stages of how buildings can be maintained by the proper implementation of BIM. But when you come to the asset management side, it is actually the later stages of construction, and what data can be handed over by implementing actually implementing that methodology is what we continue here. So by the KPI terms, there cannot be a similar kind of KPI tracking because it's two different sides to the same thing. But the asset management in itself is a broad spectrum with lots of new things, like digital twins are actually trying to improve, but many people and organizations find it very hard to actually incorporate those kind of methodologies because of their lack of knowledge on how to implement these kind of things. So my purpose through the study was to actually figure out and filter what can actually help owners and offices to understand how it can be implemented in an easier method, because during the study itself, we found out how some of the companies tried to incorporate this kind of methodology and they failed because they didn't know what they were after and how to approach the system, and they didn't have clarity on how it should have been implemented. So from the literature study and the actual interviews, we streamlined that workflow into benefits, drawbacks, and the best practices to actually do this kind of KPI tracking, which was basically time saving as well as asset tracking. Some of the companies try to incorporate this kind of methodology and they failed because they didn't know what they
Sorry, someone is interrupting. So Peter, please mute your mic. Okay. Sorry, Brian.
Yeah, I hope I answered my question.
Yeah, definitely. You totally answered. Thank you for your amazing work. I'm quite impressed.
Thank you.
We have a comment at the chat. Hello, thank you very much for the presentation. Okay, it's more like a compliment rather than a question. So we still have 3 minutes for the next presentation. Thank you, Brian.
Thank you.
Yeah, we're gonna pause for 3 minutes. Stay tuned, guys. We will be right back.
Okay, bye-bye.
Hello, everyone. I just realized we do have a question from Juan at the chat. I'm afraid we are having a delay to receive the questions. So whenever you have something to add, please drop your comments as soon as possible at the chat. Otherwise, we won't have time to ask them for the participants. And we are almost on time, so I will already invite the next former BIM student, which is Igor Guilherme, which will present his work entitled Visualization of Data Analytics using BIM Models for Enhanced Decision Making. So welcome, Igor. Whenever you are ready, the stage is yours.
Okay. Okay, can you listen to me well? Okay. I'm gonna present it here. Can you see my screen, André?
Not yet.
And also if you can confirm if it's changing slides.
Okay, I can see yet your screen, so maybe if you can share it again, please.
Okay. Can you see it now?
Okay, now I can see your screen. You can start whenever you want.
Okay. Okay, so thank you all for being here. This is my dissertation for BIM A+. As André said, my topic was visualization of data analytics using BIM models for enhanced decision making. I had Tomo and Andrade as my supervisors, and also equally to Brian, I also had a partner company. It is LS. LS is the main electricity distribution company from Slovenia, and in the person of Miha Betan, who helped me a lot. So, okay, let's start by trying to understand our opportunity, our problematic situation. And it is stated as, despite widespread adoption of BI or business intelligence tools, the strategic potential of BIM remains largely untapped within data analytics workflows, particularly in the energy transmission and distribution sector. So in the figure below, we can see the value flow between BIM and data analytics. In the down part, we can see there are a lot of sources of data, and between giving value to the main customer, we have BIM as a gatherer of all that data and a worker of all the data. So we will try in this work to diminish the gap between value being granted to the main users of BIM and data analytics usage focused on decision-making processes. Okay, so LS is a very advanced company. They have already a data analytics center very, very well structured, as we can see in the left image. In the right image, we can also see that the man is using a 3D model, but the main idea here was to have BIM models, not 3D models. In this image, they are using the 3D model, but this is just a 3D model with no information attached to it. So yeah, LS already has this very well implemented idea of giving diagnostics for decision makers using data and using Power BI dashboards. And they already want to use 3D models for visualization and stuff. So the main idea for our work was to use BIM models and not only 3D models, and try to understand what is the main issue with all of this situation. So, okay, the methodology that we used was two-part. We needed a case study, which is the LS application of data, and one specific construction, which is a substation they have to offer the data. And also, but most important to begin with, was the literature context. the literature context, we could understand that this gap between BIM spatial data and the BI tools was a very broad perceived situation, not only ALS, not specific or ALS nor Slovenian problem. This is a major problem that all of the world is mainly suffering for. And we also suffering of, and we also could understand that this is potentially one of the best moments to try to explore this problem, because we have not only BIM new possibilities, we also have AI and also big data, very well studied. So in this idea of trying to diminish the gap between using BIM in decision making through data analytics, the main idea was to make it happen, and it is a good moment. So for our case study, we are using the core technology of Power BI, and we created a case study, a broad case study that could understand between 4 different providers of 3D viewers for Power BI. We have Speckle, we have Autodesk Data Exchange, we have VCAD, and we have Flinker. Okay, so the workflow that we had here was a very simple one, a 4-step one, that we have to first identify the stable identifiers between models, 3D models, BIM models, and the data, so we can connect everything. So after that, we have to perform the data extraction and transformation from these BIM models. So we have alphanumerical data of it. After that, we have to use Power BI to integrate all of the data. And the last step was to develop an interactive dashboard with this said 3D visualization. So of course, our key challenge was going to be the first step, that it is to identify this stable identifier, this parameter that can be trusted between BIM models and data models and external data sets. So the first thing that we did to try to reach this gap was to develop this downward framework here. Once we had the data from the model divided in 4 data sets, the resources, location, documentation, and technical data. And all of them could be connected to a well-defined BIM use. So for maintenance, for quantity takeoff, clash detections, and also for all-around connection to any other external database. So yeah, we performed the work. This is a very short presentation, so we're gonna do a walkthrough for through the dashboard and talk about the main contributions we could perform doing this. So the first one was the idea to create a very stable and reproducible blueprint for integrating BIM and Power BI in operational environment, not only a data scientist environment and not only a BIM specialist environment, but something that could be used by everyone that could work with the data that is being exposed, and also the visualization. For this, we have the example of one of the pages of the dashboard. It is a page for the foundations and also for the superstructure. We have the third and fourth pages. That is to quantity takeoffs. All of the data is being queried by the model, from the model, and it can be very well connected between the main idea, the main identifiers, that is the identifiers for speckle that we have the main explanation why in the end of the presentation. So we have the total volume, the specifics of each data set, also the specific of each element in the below part. So the second page that we could highlight here, it is for the main contribution of technical pathway evaluation, because the main idea to understand which integration of those four was the best one was to evaluate the main international agreeable format for BIM, which is IFC. So we have a specific page of IFC evaluation, and so we have all of the federated model there. And Speckle came out as the winner of those four. We had Flinker and VCAD creating a lot of problems, although VCAD is a very updated and very good option. It created a problem for simple use. And Autodesk Data Connector was very linked to the Autodesk environment, so we try to avoid that. So Speckle came out as the winner for this, and the Speckle reading of the IFC model was very good. And a third main contribution we can highlight is the paradigm shift that was the main idea in the beginning of this present work, from a reactive oversight to a proactive data-informed decision-making for construction management, and with this integration between BIM and data analytics. And the main example that we have from the model, from the dashboard, it is this management of HV, high voltage equipment management page that we have by color the asset health index, querying by color the elements in the BIM model, and all of the information also being queried when the model is queried. So, okay, going to the end of our presentation, we have had a very good impact trying to pursue our goals with this dissertation. The first one is the improved decision-making support. We have done an internal survey with LS stakeholders, and the survey showed that the stakeholders reported that an enhanced process of decision-making capabilities, and also the spatial context could greatly contribute to their analytics workflows. In the image, we have a graph of perceived impact of spatial data visualization. The farthest points are good grades, and the 0 grade is I haven't used for this main idea. So all of the grades are mainly good. So yeah, as having now a conclusion and suggestion for next steps, we have the conclusion that the research could successfully establish a robust link between BIM models and company data. This can change this could change from a reactive to proactive decision-making processes. And also we had the conclusion that the Speckle connector emerged as the most effective solution for this specific case study. For suggestions for the future, we have to use and explore new platforms for this integration, as defined as development of specialized platforms for seamless BIM and BI integration with standardized data mapping protocols and real-time synchronization is the main idea of what we did with those 4 providers. And also a very good main idea from now on is to explore Autodesk platform services, the known formerly Forge from Autodesk. With the exploration of these digital twin capabilities, they already have a very good tutorial of a digital twin in the APS space for the creation of this virtual representation, not only using Power BI environment. So yeah, thank you very much for any contact needed. These are my contact information. Thank you very much. Any questions are very well received.
Thank you, Igor. First of all, congratulations. I'm speechless. Quite a good job you have developed. So I think typically people think BIM as this 3D geometric visualization models, but actually you have proved that it's more than that. BIM can work as this huge database where you can store both geometric and alphanumeric data, and even exporting this data for like dashboards such as Power BI, and integrating these two environments is quite useful nowadays for real-time data visualization. And yeah, we do have a question. Great presentation, Igor. Good job showcasing your work. Is not exactly a question, but yeah, maybe I can make a question as an icebreaker, and then let me see if there is. You are amazing, Igor. You're amazing. So yeah, can you please describe with more details how was the process of extracting data from BIM models and integrating this data somehow at Power BIs, if you have any issues or problems throughout this process, or even have you ever thought about expanding and escalating this project for, I don't know, integrating data with CDEs, or I have so many thoughts at my mind by now. So yeah, can you please describe how was the process?
Okay, so the initial main idea here was to create a very broad study. The idea that I put in the suggestions of creating this digital twin was initially an idea to create the work during the dissertation, but at very early stages, I understood that it wasn't feasible in the meantime. But all of the external data that we use here are being queried from some kind of cloud service. The CDE could be treated as a cloud service, just like this one. And what was the first part of the question? I'm sorry. The process, right?
Exactly.
Yeah, so the process, during the process, we used a lot of, we tried actually to use a lot of alphanumerical manual parameters from the models to identify. But the best one was the IFC identifier, the normal, the regular IFC parameters. So we couldn't use very much of a good for a lot of different types of elements as we have here. We couldn't use like manual data, manual inserted data. So yeah, we used that's why Speckle was the best one, because Speckle really treated well this IFC identifier.
Okay, that's great. We still have 1 minute left, so maybe you can quickly reply a question that just popped at the chat. So how do you integrate those in Speckle? So at the end of So at the end, you are controlling everything in Speckle.
Could you repeat it, please? The first part?
How do you integrate tools in Speckles? This is the first question.
Okay, how do you integrate tools in Speckle? Speckle has a full service in a web-based interface that we put our BIM models there, and then during the ETL part in the dashboard on Power BI, we can try to find every information. All of the IFC information is there, so we can use the IFC, and all of the Speckle specific information is also present in the query from the database from Speckle.
Right. Igor, thank you so much for your contributions.
Thank you, Andre.
And good luck in your next step. So now I will please invite Manasseh Tete. Manasseh, if you are online, please. Okay, you are here. So welcome aboard, and yeah, the floor is yours.
Thank you, Andre. If I can share my screen. Is it sharing?
Not yet.
Perfect.
Okay, now I see our screen. Just put, yeah, okay, so here we go. Good luck.
Thank you very much for the opportunity to contribute to this wonderful conference. My name is Manasseh Tete. I'm a civil engineer. And for my research, I studied on advancing infrastructure BIM through integrated spatial data and enhanced data extraction. I did this under the supervision of Assistant Professor Yene Tebacek, PhD from the University of Ljubljana. So BIM actually started out to be a bit more building centric in that it's involved more of physical building and less of civil infrastructure. But in the recent years, BIM has evolved to involve a lot of civil infrastructure. And this is very evident in the IFC 4 and the subsequent IFC 4.3 versions. And to the screen, we can see a typical BIM model of a bridge. And we can see in this slide how immediately adding spatial context to the BIM adds a lot of meaningfulness to the model. However, integrating BIM and GIS has not been easy over the recent years. There are a lot of challenges, which include georeferencing files. There are also the file formatting, because both BIM and GIS were created for different domains, and they target different file types and different end users. So this has always been a challenge. However, in the process of integrating BIM and GIS, we have three main options. There's an option to link a GIS file to BIM, which this project focused on, but there's also an option to integrate BIM to the GIS environment. There's also the third option, which is integrating both BIM and GIS in a third-party environment, like the semantic web technology. However, we have to pay attention to the tooling mechanisms available to engineers and architects at the moment. By that, I mean that to integrate BIM and GIS, it's always best to go by the methods that engineers and architects are familiar with, so that in the long term, we can scale up to include things like semantic web technologies in the BIM environment. So this thesis had three things in mind. The first thing is that we wanted to pick a raw GIS file. However, in the past or in recent times, integrating BIM and GIS has come to focus a bit more on things like CityGML and LAN XML. And all of these GIS files are semantically rich. However, GIS information is not only 3D. GIS information also includes 2D cadastral data, topography data, and land mapping data. And it's important that we look at ways you can include 2G GIS files in BIM environment. And that was the focus of this thesis. So my research goals was to examine if IFC is suitable to be used as the file listing medium to integrate 2D GIS data in BIM environment. Also, we wanted to do this while observing the spatial hierarchy in IFC. because in IFC, spatial hierarchy is always important. And every object in IFC has to be contained in a larger hierarchy. And the third option is to test the created IFC if it's responsive in the BIM environment in the long run. Because BIM, as we know, is not only the model, but it's also the information or the metadata that is included in the model. So to do this, I picked a project I worked on in 2020, which was a BIM-based project. And then I took the middle zones, which included zone 4, zone 5, zone 6. And these zones included substructural elements, that's foundations and power caps. And then I wanted to create, this data existed in 2D, the zoning information. So the idea was to create this zoning information in GIS that we can integrate into BIM. And to do this, on the right side at the lower bottom of the screen is the spatial hierarchy adopted for this. As we know, typically in IFC, the typical decomposition is IFC project, IFC site, IFC building story, and then we go to IFC spaces. However, the spatial hierarchy adopted for this thesis was the IFC project. And then we have an IFC main site into which the other sites were aggregated. And so to start this, the first thing I did was to create these zones in QGIS, which is a popular GIS software used for manipulating GIS data. So the various zones were created, which included zone 4, zone 5, and zone 6. And the most important thing that was observed in this creation process were the attributes associated with each zones, because the main goal was that this attribute should be able to integrated into a BIM environment and possibly be queried for design analysis or design validation. So this shows how the various data in QGIS were created and to be integrated to the BIM environment. So there are a lot of ways we can bring this GIS file into BIM, and the IFC was chosen for this thesis, obviously. However, the software that was used to integrate the GIS file into BIM was the feature manipulation engine, which is a data manipulation file popular with the GIS profession. And the whole process in FME is summed in this slide. The first thing is to convert the GIS data to FME. And the next stage is that I extruded the GIS 2D file into 3D so that we can adapt it to the existing IFC object representation. And you also have to know that in IFC, there are a lot of object representations. There is the boundary representative, there's the tessellations, and there are a whole number of shape representation. So the first stage was to convert the GIS data to FME. The second stage included extruding the geometry to 3D. The third stage including creating the property sets for the GIS data. And the last stage included creating the property set definition. And so to adopt this workflow, the IFC attribute and entity inheritance was used, to mirror this workflow in QGIS. And as you can see, the various correlations or the mappings correspond to the IFC entity inheritance. So the IFC entity inheritance informed my workflow in FME or the feature manipulation engine. And then we also have to observe from here that in IFC, some things are constant, like the IFC root, which contains the data for the components, like the name, the description, and the owner history. All of this has to be observed in creation of the IFC file. So to take you quickly through my workflow in FME, the first included creating or instantiating the IFC spatial hierarchy, which you can see from this slide. So the first slide is sampling the metadata in the imported GIS file, which is very important because most existing literature, the integration of GIS to BIM does not consider filtering data as an important step in the translation process. And this has been highlighted by research as a major gap, which leads to huge storage demands, and in most cases, data latency because of the sizes of the files that we operate in the BIM environment. Also, we can see from the third workflow that the spatial aggregation is, or the spatial hierarchy is instantiated. We can see from this slide, the FME IFC real aggregate ID. This is the main component that links each and every zone we created to the main spatial decomposition. And all the three sites are linked to the mother site through the IFC relationship aggregate. And then this workflow will be written to an FME writer. And so this is a summary of all the steps that was observed. The first, the data was filtered. Second, the spatial decomposition was initiated. And then all three zones were tied back to the main parent sites through the relationship aggregate. And for the second step, we had to create the geometry. And we should be reminded that the geometry we are working with here is an ordinary planar 2D file, which has to be brought to IFC. So the first stage included extruding the 2D file into 3D, and then assigning an object representation in IFC so that our model can be recognized as an IFC compliant file format. So this stage also, from here, we created the attribute, which is basically mapping the ordinary GIS attribute to IFC compliant naming patterns. And from there, we created the geometry property setup. And it is very important to create the metadata or the attributes that are associated with the geometry. In summary, at this stage also check the 2D spatial data and make sure it was extruded to be IFC compliant. And we created a predefined type. Also, the geometric property setup was used to transform the attributes to the associated model. Quickly to the third slide. On the third slide, we created the property set. So the first we did was to instantiate the spatial hierarchy. The second was to create the geometry. And the third slide was creating the property set associated with the geometry, because we know that BIM is not only the model, but also the information associated with the model. So this step primarily concerned about creating the property set associated with the GIS file we just extruded. So to sum it up, we created a property set here also. And the property set, to sum it up, included geotechnical investigation reports, which ordinarily will exist in different file formats like Microsoft Word or PDF files. But here, we are able, through FME, to merge this geographic and geotechnical information into the model. And the last step in the workflow in the feature manipulation engine included creating the property set definition. Now, this is very important because in IFC, every property set has their own specific data type. It could be a Boolean, it could be a single value, it could also be a naming according to the IFC pattern. So in this case, each and every geotechnical investigation report was mapped to the appropriate property set definition, so that in IFC, these values can be identified and even queried for design purposes. So in summary, the ordinary GIS file, which was existing in 2D, was created into an IFC compliant file, a step file compliant file. And we can see that the typical IFC data was associated with our created GIS file. But there were a few important things to highlight because you can see that unlike other attempts here, the created IFC file from the GIS model observed the individual sites and their associated attributes. As you can see that each and every site here came with their own soil type. And then the other versions also shows the other attributes that were associated with the GIS file before conversion. But it is important to also note that the coordinate reference system is a huge issue in BIM and GIS integration. And for this thesis, our prerogative was not necessarily coordinate reference system. However, this study demonstrated how having an exchange information requirement can go the long way to make design and feasibility study a bit quicker. Because in this design, we adapted the IFC model, we changed the survey point in Revit to obey the GIS information. And from the created model, we can see that because IFC typically stores its coordinates in local reference systems, IFC interpreted the coordinate reference system as a local coordinate system with huge X and Y values. Also, as you can see, the ordinary 2D file, which existed as just lines, were now converted to a 3D file, which was integrated into Revit, which was the BIM tool selected for this study. And as you can see, all the zones observed, their spatial boundaries. However, it's important to point out that this used a typical flat site for the study, but in a site where you have varying contours or you have a terrain with undulating surfaces, the same can be done for it, and then you can design having the spatial context of the site in the background. And so the last objective of this research is to try and see if the created IFC file from the GIS data can be queried for design. And ideally, I had intended to do this using a Python Revit or PyRevit in the Revit environment. But before I did that, I had to test if this is going to be responsive in IFC OpenShell before proceeding to work in the PyRevit. However, there were interesting observations here, and my research corroborated, or my research reaffirmed what other researchers had discovered in the past, in that it is not easy to query the data that was created from the GIS environment. There was a typical landmarking test that tested 33 different softwares on their responsiveness to GIS data that was converted to IFC. And they all face a similar challenge in that it is very difficult at the moment, except using semantic web technology, it is a bit difficult to query data directly from an IFC file created from a GIS information. Also, to try to verify this discovery, I tried to query this data in Dynamo in Revit, and I ran into the same hurdle in that Dynamo is able to identify that, yes, there's a linked model, but Dynamo is not able to proceed further to query the data which is inside this linked model. So the conclusions are that our research extends the BIM and GIS integration options, in that previous options had looked at converting CTGML and LAN XML files into BIM. However, GIS has around 200 plus file size, and to extend the effort of integrating GIS and BIM, other file types had to be tried, which was the prerogative or the objective of this research, in that the file type, the GIS file type used was a shapefile format, which is a file format that typically municipal sites use to store the geographical and terrain models on their website. And we can see this in the municipal data for Germany, for Holland. And I also discovered during my research, there was a site for Ljubljana or Slovenia that has the topography of the entire city. Also, IFC proves itself to be very flexible in integrating other different file formats into the BIM environment. And the last thing also that was discovered, which was not an entirely new discovery, is that there's an existing challenge in querying data, GIS data, that were transported or integrated into BIM environments. And also it's important that subsequent IFC versions take notice of this obstacle and try to create the IFC in a way that will be a bit favorable to integrating GIS environments. And so in a nutshell, this was the study I undertook. And for future research, they can try testing various IFC sheet representations to see which one responds a bit more to queries in BIM native environments. Additionally, a GIS and BIM integration that uses the new IFC5 format should be tried to see if some of these challenges will be solved in the new IFC. So in brief, this was what I studied for my thesis. Thank you.
Manasseh, congratulations. Fantastic work you have done. Is indeed our topic to explore in a PhD. I don't even know how you managed to to do everything in such a short time. But congratulations again. I'm afraid we have yeah, the time has passed. Not sure if we have time for further questions, but just congratulations again. The infrastructure projects that use BIM is a quite complex topic, especially because of all the issues that you have pinpointed, such as georeferencing, BIM models in IFC domains or vice versa, and also the issue about converting data formats, either IFC to CityGML, CityJSON, or whichever. So yeah, congratulations again. We don't have any questions at the chat, so let's stick to the schedule. So thank you. And I invite now Giga to present his work. So Giga, please share your screen, open your cam, please. Yeah, here you go. So the floor is yours and good luck.
Yeah, I just have one problem. I will just need to quit and reopen the Zoom, and then I will start. Okay.
I just kindly ask in the meanwhile to Peter Barbu, please close your mic.
Hello, it's me. I will try again because I have issues with sharing the screen and the permissions. I think now it will be good. Do you see my screen now?
Now I see.
Okay.
So,
and you also hear me?
Yeah. Perfect.
Okay, perfect.
Good luck.
Okay. Okay. So here we go. Yes, my name is Giga Vejovic, and I will present you my thesis work under supervision of Professor Thomas Saroshek and Mr. Jure Česnik from LEA company. The title is Tracking and Restoring IFC Identifiers in Cross-Platform BIM Workflows. And let's first clarify about identifiers and what is cross-platform. So we are using identifiers in our daily life. We have names and surnames, which are descriptive identifiers, but to be identified globally, we need one unique identifier, which is national ID, and with that identifier, we can enroll into a study program or go into a bank and open bank account or own a car. And the same concept can be applied in BIM. Each model have its own GUID, each element have GUID, and with those GUID, as we heard a lot of GUIDs today and linking data, we can integrate element into different workflows, for example, cost estimation or energy analysis or facility management. But the problem is that in our real lives, we have persistent identity but in BIM is known that identity is often changed for different reasons. But then is the question, why then link information and data to identity? Is another ways of linking information, and of course, yes, we can link elements into workflows by filtering them, but this is good just for cost estimation or preliminary studies, for example, phase visualization. But if you want to connect, for example, sensors or important documents, that should be linked to element identity, and also is for construction site progress tracking. If you want to click elements that are completed, we need to click just to that element, and that means that we are choosing element by its GUID. So because GUIDs are not persistent, my work was my idea was to research if we can make GUID persistent and discover why the change of identity occurs. So in the first step, I did empirical study of identifier discrepancies in two main authoring platforms and in one plugin for Revit, so script-based modeling. And then I did also some import-export round-tripping with IFC files, and discovered that GUID is more or less persistent, but the problem is that when round-tripping models, the platforms is changing the structure of the model. So GUIDs of parent elements are persistent, but their child elements lose the identity because Revit, for example, just takes the geometry, not building element part with its identity, but just take the geometry and combine that in one element. And then in the next step, I want to discover if we can track changes beyond GUID discrepancies with 4 functionalities. So is GUID independent change detection possible? Can we link data to GUID, and what communication possibilities there are? So Excel export and BCF communications. 6 platforms were tested, and it's important to mention that no software warned us an issue if we broke the connection. So yeah, that was concerning. And then because there's no platform that will allow tracking changes beyond GUID discrepancies, I decided to develop my own script. So in the first step, I needed to understand the language and schema. I choose Open Schema, IFC, and Python as widely used programming language between engineers, and IFC OpenShell as bridge between Python and IFC schema. When I was familiar with the language, I started prototyping with ChatGPT and Claude, which was proven to be better for coding. But you know how is with AI, sometimes with same prompts we get different answers. So that's why I created a structure and clarify the functions for each step. I created two diagrams, one high-level flowchart from user perspective, and one modular architecture diagram for coding, which was then used in the next step. And in the next step, I created my coding environment, which was Visual Studio Code integrated with Cloud Pro. So you can see here on the right that I was also coding with just human language. And that's the beauty of AI. You can just structure what you want and tell AI create me Python code from human language. But it's important to mention that if we are coding like that, AI is constantly overwriting our files. So make sure that you connect to GitHub repository, because it happened to me that Cloud Code deleted all my project. So yes, two things: establish GitHub and never say to AI delete anything. When script was developed, I saw that there are some issues with the performance and that the geometry extraction needed optimization. So I benchmarked 13 functions with combination of accuracy and performance, from basic bounding box centroid calculation to volume weighted centroid, and from basic Python for loop to IFC OpenShell iterator. And at the end, I chose centroid volume iterator because if I calculate centroid volume, if I calculated volume weighted centroid, it's the most accurate centroid. And in one step, I calculate both the centroid and the volume. And of course, I used the IFC OpenShell iterator because it uses multi-core processing and it's the fastest option. So the final result, the idea looks like this. We insert the two IFC models, reference and new model, and select the output folder. Then we input the tolerances for centroid and for volume, and we can match element by IFC type. And we can choose the target property set and choose the export option. And as output, we get structured change report in Excel and IFC file for visual inspection and with recovered UIDs. Now let's look at how script works. So we insert the reference and new model. Select the output folder. Load the models. Then we choose the tolerances and the target property set BIM A+, and start the analysis. Export results. Now we will look at the tiled Excel first. Okay, so we have old and new attributes. You can see old UID, new UID, and the properties. And as we selected, we see just the BIM A+ properties. And at the end, we have the summary of the analysis. Now let's look at the IFC colored model. We see the elements are color coded, and we also have the property set changes written, so we can filter element by properties. And of course, we also had all the GUIDs in element, which GUID was changed. Script was then validated on 3 case studies. In first case study, we want to check script on script-based modeling progress tracking. So as we know, if we would insert a model created from Dynamo in basic change detection platform, all elements would be colored green because the platform will recognize just new GUID, but in reality we have same element, but just the identity is changed. So with my script, we proven that some elements existed before and has new identity, and those elements are colored red, and the new elements are colored green. In the second case study, I wanted to try script in 4D and 5D BIM workflow, but just the basic concept, and that was quantity takeoff. I created one work items for calculating concrete columns volume. And as you see in the left picture, in first selection set, we have 12 columns. And then I created a new model and altered 4 GUIDs. And if I imported that model back into the platform, those elements were not included in these work items. So correspondingly, quantity was lower. And after applying my script to map the GUIDs, the quantity was the same. And in the last case study, I wanted to try issue management with Solibri and clash detection function. I created BCF files with reference to elements, and then again change some elements identity and imported new model in Solibri. And as we see, the link to elements was again broken, and after applying a script, the references remain the same. Here it's important to mention that mapping should be done before introducing the platform new version of the model, because if we import altered model, or let's say change model with change identities, then the platform will delete all the references, and in some cases also the data and information. I would like to conclude with future directions. For the script, I think in the next stages it would be good to have interactive user interface so that user could review paired elements visually, and also machine learning could be implemented to detect the semantic meaning of elements. And I think that this functionality should be integrated in BIM management platforms. And at the end, I would like to conclude with the idea that arise during the thesis work, and that is side BIM. As we know, the software developers and on conferences, we are all talking about one model in which everything is connected, but the reality is that each discipline needs to build own model for their workflows. And I see that maybe the path to one model is to discover more about site processes. So for that site BIM, and I see that we should have one model and data connected to GUIDs, but that we need to discover site processes, how to map identities, and how to transfer different kinds of information between the platforms. So yeah, I think we need to step aside to discover those processes and think out of the box. Thank you for your attention.
Thanks so much, Giga. Excellent work. I see great potential for escalating that to other European projects, such as material traceability passports and many others. So it's amazing. Unfortunately, you are running out of time. We no longer have time for any questions. But congratulations again. And yeah, it's been a pleasure to host you in the second afternoon session. The next meeting will be held tomorrow at 9:30 Central European Time, guys. And yeah, see you there. Thanks so much. And it's been a pleasure. I declare this session over. Thank you.